Good morning, everybody. Hopefully, everybody had a good party. You kind of look lively. Coffee is still outside. We're going to go for a while. We have a long talk today, and we're going to talk about mobile security. It's an interesting topic. I think it's a very timely topic, given what's going on in the world today and some of the applications we all get to build and to use. So we'll spend most of the day talking about both some theory as well as some live demonstrations of how to take an app that somebody else wrote and look inside, and how to find things that they did that they shouldn't have done. Before we get into that, I work for a reasonably large company, so the legal team makes me put this up. The opinion in these presentations are mine, my own only, and they do not represent Oracle. Today we'll talk about some mobile stats and what's going on in the mobile ecosystem. We'll talk about OWASP, the Open Web Security Project, Application Security Project, and then we talked specifically about the mobile part that spun up about 3 years ago at OWASP, focusing on mobile security and mobile threats. We'll do a bunch of live demos, and we'll have some time for Q&A. We will also, by the end of this presentation, find out what's the meaning of this. As I was prepping the slides a few days back, and this came up through one of my RSS feeds. And if anybody here at home uses D-Link router? Any D-Link users? Yeah, there's one too. You will find this string very useful and very interesting. I'll explain why at the end, so you have to stay if you want to know. So a bit about me. I'm based in California. I've been doing Java application development for about 12 years. Spent my entire career building online applications. Started my career working for an internet service provider in Israel, one of the earlier ones. And then kind of shifted gear to software as a service. Been doing software as a service before software as a service was known as SaaS. We used to call it ASP. SaaS is a way cooler acronym. And I've joined Oracle about a year and a half ago through an acquisition of a company called Taleo. We were one of the largest software as a service companies in the world. Still do what I used to do at Taleo. I'm on product development for several products, including a mobile team. As well as I'm a member of what Oracle considers an extended global product security team. We have about 27,000 engineers. We take security of our applications very, very seriously. And there's way too many engineers for one centralized security team to handle. So we actually have more than one. We have 3 or 4 different security teams. And they all have expansions into the product lines. And I'm the member representing the product lines that I have. I also like to travel, so coming to Krakow, this is my 3rd time this year. You guys have an awesome city. We got lucky with the weather with Pablo over the weekend. So let's get into it. Let's talk a bit about mobile. I'll date myself a bit. Any Trekkies in the room? Star Trek fans? Darn. Oh, one. Yes. Dude, man, Star Wars here. So again, I'll date myself. I was growing up in high school watching Mr. Jean-Luc Picard hand those things around. I was like thinking about this. Wow, wouldn't that be cool one day if we had one of those things and I could just carry it around? And not 20 years later, I have 3 of them. I have the iPad, the iPhone, another tablet somewhere at home that I probably forgot about. This stuff is evolving really quickly, and because it's evolving really quickly, it's also creating problems, right? Why are we here today, specifically in this talk? Well, the mobile is going and exploding like crazy, right? And the users of our applications that we tend to build expect to be able to do everything they do on the desktop or in the browser on a mobile app. And those expectations are only going to get worse. The products I work on are business apps that are built for HR users or managers. And we have a very strong push to get as much as we can of our functionality into the mobile device or a tablet form. Right? Mobile computing has certainly arrived. A few years, the stats were probably lower, but today, 91% of everybody in the world has a cell phone. 56 of those percents are already smartphones of some kind. And it's a bit of a struggle right now because the capabilities will vary, but smartphones are certainly here. 50% of those users, right, use mobile as their primary way to access the internet. Some people, including my parents, who have recently converted from their desktop that I don't want to support remotely, they live on the other side of, I'm in California, they're in Toronto, in Canada. They're very happy with a tablet. What they need to do, email, Facebook, on occasion, video call to relatives, works well for them. They don't even touch a computer anymore. And 80% of all the mobile usage is typically spent in the apps. It's not the browser. So the apps are extremely important, which means they're a very attractive target to be attacked. A lot of e-commerce is starting to happen online, banking, transactions, stuff that is sensitive, not just your kind of Angry Bird stuff, right? Who cares about, if your high score gets stolen, you may care, but if your bank account gets compromised because the mobile app was not developed correctly, that's a bit more problematic. Business is coming online as well, right? 80% of consumers are planning to conduct mobile commerce in the next 12 months. That's a lot of traffic. Because of that, the vendors are rushing to go online. Now, it's all cool, it's fun, it's very easy to use. The battery life is awesome. I could charge my iPad before the flight from San Francisco to Frankfurt and still have battery left at the end, not my laptop. But the problem with mobile devices, they're small and they tend to get misplaced, lost, or stolen, right? They get stolen in all kinds of weird places. I love this stat, like second most likely place you will lose your phone is in the store. Fourth one is a coffee shop. And the interesting stat in the US is 113 phones are lost or stolen every minute, right? That's about $7 million of phones worth a day get misplaced. Now, mobile doesn't make being secure easy today, and that's a problem, right? Those little tiny keywords, and I love what Apple did in iOS 7, because now when I type my passcode, it highlights the freaking button that I just pressed on, so everybody around me knows what the digits are, right, Pablo, as we did this morning? The keyboards are tiny as well, so trying to enforce user security with complex passwords ends up just doing nothing but frustrate users, right? So I'm personally very excited that Apple is doing this. I played with a couple of them. This actually works quite well. Like, not typing, and because I work for a company that deals with HR data and we're a software as a service company, I have an 8-digit code locking my phone. So not having to type it while I drive, that's just by touching this is going to be awesome. But let me ask you guys, how many of you have a passcode on your phone? Okay, 1, 2, 3. We'll ask another 4 maybe. We'll ask another question at the end. Perhaps you will change your opinion about not having a passcode on your phone at the end of this presentation. Now, everything I mentioned, right? The mobile computing evolution, the desire of businesses to transact on mobile is creating a gold rush, right? There is a tremendous push to build mobile applications. There's a tremendous push to expose more and more functionality to mobile. But quite often, much like during the gold rush, things are done quickly, not always securely, not always properly, not always by the people that understand all the fine nuances of developing mobile applications. And there's plenty of those, as you'll see. Reputational risk is high. As much as all of us love our products to be in the news, I doubt it's the news like that, right? This is a fairly, I don't know if you guys are familiar, they're very popular in Asia and US. WhatsApp is an SMS replacement company. They claim 300 million active monthly users, bigger than Twitter, as they call themselves, right? This is an article from 4 or 5 days ago of a security researcher accusing them basically not implementing RC4 crypto according to best practices and potentially exposing their users' traffic to simple decryption attacks, right? So if you don't do it right, you will be a target, somebody will find this, and you may end up like that. So that's why, and I think it's extremely important, and I think we'll continue to see articles like that. So let's talk a bit about Open Web Application Security Project. It's not a new project. It started in 2001. Started by identifying common threats to web applications, right? That's where the original charge of that. And over time, the project have evolved by identifying threats to cloud applications. And in 2010, they have published the first draft of the OWASP mobile top 10 threats, which is what we're going to be covering today. So let's quickly look at the typical OWASP top 10. They just republished the new top 10 in 2013. Who is here familiar, heard of, used, or knows of OWASP top 10? All right, about a third to half of the room, right? Those are the typical things that web applications today can be vulnerable for. And if you do have a security team in-house, or if you use a third-party penetration firm to test your applications, typically this is where they start, right? Injection, XSS, SQL injection, XSRF, insecure object references in your HTML, sensitive data exposure through headers, missing access control, not patching your software, whether it's the operating system or some third-party library that you've embedded in your product. For example, Hibernate not too long ago had a security bug, right? And the list has changed a bit, so they merged some items. The 2010 is slightly different, but it hasn't changed substantially. So the mobile security project started in 2010. There is a URL. It's linked off the OWASP mobile site. Most of the content that I'll be talking about is available there. So you can always refer to that site for details. Now, when we think about security in general, one of the first things you do when you think about securing your system is this exercise called threat modeling, right? And the best way for me to describe threat modeling is to go to the source of all truths in the universe, also known as Wikipedia, and just cut and paste their definition. And there are really two ways of thinking about what threat modeling is, right? You can either think about it as a description of the security issues the designer cares about, we as the designers, right? Or the other way to look at it is, when you look at the piece of software, right, how can you attack it? What are your vectors, right? Where can you come in, and from which side of the application you come in? And I prefer to do the latter every time we do a threat model for any application I work on, right? So, when we think about threats, right, what do we need to protect within our application, and why? How can we get attacked, right? Where does attacker come in, and what can they do? What can go wrong? Do we have the protection for those specific threats that we have identified? And of course, what the risk we have, and can we accept that risk, right? At the end of the day, we all write applications where there's a trade-off between the effort it takes to fix something or the usability of the application and the risk that we're going to expose something. And what is that we're going to expose? You know, if somebody is able to extract the first name or the last name or some preference from the app, who cares? If somebody can extract my credit card number out of the application, well, I, as a user, care a lot about that. And one thing that makes it mobile specifically difficult for threat modeling, that for the last 13, 15 years, all of us have been building web apps. And if you think about the mobile applications, the traditional web application is a client-server app. So all of those skills that we all had, or some of us who are old enough had, of client-server apps and thinking about client-server apps differently, kind of slightly, they're going off the market, right? So we're kind of going back to what client-server used to be. Unfortunately, not the best diagram, but the closest I could find. When you think about the threats that your application that runs right here, right, can be exposed to, the variety of trust boundaries, there's the network, right? And in spite of what we think, GSM network is not really secure. Has been penetrated a number of times. There was an article recently in the news about FBI using fake cell towers just to get your signal when you're in a particular vicinity so they can watch the traffic. There's a response to that. People are starting to whitelist towers and make sure that there's a patch, I think, coming for Android that will allow you to say only to connect to those known towers. Let's see what the FBI will respond with, right? Bluetooth and NFC is also a trust boundary. It's an external network and not always securely implemented, especially NFC. Hardware extensions, some phones support those. Obviously, the carrier network we talked, there's the Wi-Fi, and then there's the operating system itself. Some operating systems do better than others in protecting the application and kind of creating a nice sandbox for it not to be intercepted or exploited. And at times it comes at the cost of usability. I'm an iPhone user, and you know, I don't have certain features that I like about Android on this, but I also know that certain apps cannot see what other apps do as easily as they can on Android. So understanding those OS differences becomes extremely important in order to designing your threat model, because your threat model for the same app that you build for Android and iOS will differ. And we'll see a couple examples. Now, before we get into the meat of this, I have to give you guys a word of caution. As somebody who has been dealing with security for a while, what I'm about to show you can be used as attack vectors against real applications. My ask for you is please do not, especially unless you have authorization. In some jurisdictions, even the simplest stuff can land you in a lovely hotel room like this. And there were cases in the US where on the iPad launch day, a gentleman who I would consider a troll attacked a very small key space that was used to register iPad users and pretty much got an email address for everybody who bought an iPad on the launch day. Right? He just, I think, is about to start serving his sentence, something he just got sentenced. So again, please, use what I'm going to show you responsibly. Your own applications, absolutely. I'm also going to talk about this project GoDroid. Open Web Security Project has a dummy web application that you can always play with that demonstrate all the typical security vulnerabilities. There's one for Android. It's called GoDroid. It was built by the same guys that put together the mobile top 10. It's available for free. You can download it from this URL. It's also linked from the OWASP mobile project. And I'll quickly show it to you because we will be using it for some of the examples. So let's switch gears and hope everything works. So here we go. So this is what you download and launch. It's this little kit ships with 2 different mobile apps that are vulnerable for a variety of those exploits. One is called 4Goats, and the other one is called Hurt Financials. Today we'll be playing with 4Goats, and you can always download them and play with those examples. It does have a web service built in, so there's a server component, so your web app doesn't have to exist in a vacuum, and you can play with that as well. There's a couple useful features you basically configure. It has some tools, for example, for the server stuff, you can play with you can look at the database. So there's a little SQLite built in, so you can mess with data or see how the data is stored on the server for convenience, or if you need to manipulate it. Right? It comes as one package. You download it, you install it, you configure it, you point it to the Android SDK, and you're good to go. Right? When you launch it in the SDK, in the emulator, it looks something like this. So let me just go back to the main screen. So here's the app. I already have it installed. If you ever used Foursquare, this is an app that pretends to be like Foursquare. You can check in places, you can log in, etc., etc. And that's the app we'll be kind of playing with. So I can log in, see my history of check-ins. I can register a new user, etc. Now it's going to be stuck because it needs my location. So we're going to using this lovely Telnet interface. Send the location to the emulator, and I can check in, etc., etc. Right? So, fairly basic apps. I'm going to log out and kind of leave it be for now. We'll come back to that. You can, as I said, download the project yourself and play with it, and you will be on your way. So, mobile top 10. Here's the list that the working group put together. And we're going to go through this list one by one and talk about every single type of attack vector, some of, I think, 4 different examples. And for every one of them, we'll also talk about the mitigation techniques. All right? Starting everywhere from insecure data storage to something like what we've seen in the news article, M9, broken cryptography. So, insecure data storage. Well, the good news about data storage on mobile device, choices are broad. You can do a lot of different things. Not all of them are secure, and unfortunately the security of what you choose also varies by platform. iOS provides a fairly decent security mechanism with hardware-level encryption. So when your phone is locked, the data is encrypted. The keys are stored on a physical hardware, so they're very difficult to extract. Not impossible, but very, very difficult to extract. And you have a variety of mechanisms of storing it. On Android, you also have a variety of storage mechanisms. Some are less secure than others, and if you're not leveraging the Android OS security properly, you can get in trouble there. And if you want to do things like crypto at rest, Android, at least in our experience, is a bit more difficult, right? SQL does iOS does a pretty decent crypto at rest, which means the data is encrypted at rest, and if the device is locked, even if you have the actual flash extracted from the phone, it's very difficult to read. With Android, you quite often have to roll your own, and when you do, please be careful because you need to make sure the crypto is right. Then, of course, there's a cloud, right? Because this phone, like my old BlackBerry used to do, backs itself to the cloud. So if I get a new one, type my credentials, all of a sudden it becomes my new phone. I love it. But If you didn't do what Apple prescribes, you may end up backing stuff that the user never wanted to leave the device, right? And Apple being an American company, if they ever get a subpoena from one of those 3-letter agencies, most likely will disclose your information whether you like it or not, right? And this is not a perceived, this is a real attack. And if you look at this just recently, for example, Android, if you have your Wi-Fi passwords stored and backed up, it goes to Google. iOS actually annoys me as a user because every time I get a new device and I restore it from the cloud, I have to retype all my passwords, but at least Apple doesn't have them. So everybody who stores the Wi-Fi password and backs up to Google, well, they have a copy. Sometimes applications are not very responsible about what they do with your data. There was this big brouhaha with the product called Path that used to upload your entire address book so they can discover your friends and recommend friends. And they were actually, instead of, for example, hashing your emails, they were storing them clear text on the server, right? So data can leave your device whether you realize it or not. And sometimes it does in most inconvenient, unintended places, right? How do you mitigate this? Well, you crypt, and I beg you, and we'll talk about this, please don't create your own implementations of cryptography. This stuff is hard even for people that do the research for years and years and they make mistakes. Don't try. Just take something off the shelf, or even better, rely on what your operating system provides. Make sure you manage file permissions correctly. In both iOS and Android, when you store data, you can make it exportable, go to the cloud, private, etc. And I've seen applications that will store a password encrypted in a preference file, but it's world readable. Well, that's awesome, because any other application on my device can get it, upload it, do a dictionary attack against it. It's considered a best practice not to store anything on the external storage areas because they're much easier to steal and compromise without the user's knowledge, right? Like those SD cards come out of the device pretty quickly. So I'm going to actually, today this is one of the few times we're going to go to iOS demo. I'll show you a tool that you can use to see what's going on within your own application or other applications. But again, I encourage you not to do anything that would land you into a lovely hotel room. It's called iExplorer. It was originally built for simply backing up your phone, but quite often used in security tools. And I'm also going to do something really, really brave. I'm going to plug in my own phone. So please, if you see anything that you're not supposed to see, don't use it against me. Let's see. I need to unlock it and plug it in. Yay, it worked. Thank God. Okay, so this particular application shows you a variety of things you can browse on the device. We'll start with the apps. That's the more interesting part, right? So for every app I have installed, and I have a lot, you can kind of see what the app stores inside. For example, here's my airplane app. This is a frequent flyer program that I use. I'm from Air Canada, right? And I can very quickly see what it has in the temp files. Caches, that's kind of cool. Snapshots, nothing here. Cookies, pretty clean, right? And then, of course, I can get access to the app itself. Let's see what else. What else am I brave to show? Let's try American Express app. Oh, card art. They have pictures. Fortunately, it's not my card number, but, you know, I guess they downloaded one from the server. Snapshots, what else is in here? Some OpenGL stuff, some binary cookie file, something to explore later on, right? That's kind of what's inside, etc. It's quite convenient, and when you build your own app, here, let me show you one more that I use a lot. Anybody here heard of a product called TripIt? It's a little travel organizer. You get all your travel confirmations, you send the email to that, it parses them nicely, it tracks my flights for me. So TripIt here, what do they have? Let's see. App support, caches. No. Cookies, preferences. Oh, preferences. That's kind of cool. Let's see what's inside. IDs, system names, some generation time, some dictionaries, some sessions. Lots of interesting data for me as somebody who tries to break into the application to figure out how do I want to take advantage of it, right? Let's see what else I can find inside. Store kit, that's for iOS stores. Ooh, caches and Flurry files. And let's see, documents. Oh, check this out. That's a cool file. OWASP SQLite. I wonder what's inside. Probably my OWASP token that I used to connect to the server, which if I can extract out of here, I can probably do something with it. I've already downloaded this lovely file, so let's use an SQLite tool and see. We know it's an SQLite file. Sorry, SQLite 3. Let's see, dump. Cool. I can start playing with this. Now, fortunately for me, it looks like even though my email is exposed, so if you want to send me some travel itineraries, this is where it goes, and then it shows up in my app. Rest of the stuff seems to be at least obfuscated, unless this is one of those things, is the OWASP token, right? So I can start playing with this and see what I can get to, and probably start exploring what's inside this obfuscated data, right? Because the other database I was able to extract from the app. Nope. That's the one I want. Dump. Bunch of indexes. Wow, they're serious about this stuff. Bunch of encoded data. So, wealth of data to play with. Whether the developer wants me to play with that data or not. Which means if I can mess with this data, I can potentially mess with the application if it has any bugs, right? I can inject some of my own data directly, unless they're verifying the data integrity. So the only lesson here is think about the data you store, think about where you store, think about how you store it, and what type of attacks can be executed against you if you do that. Next one, weak server-side controls. Because we can always trust the client to tell us what's right, right? The mobile application, much like a browser, needs to be treated as something that is not in our control, right? The moment we put the code out there, it's on the App Store, somebody can modify it. Somebody can use the same API. So the client cannot be implicitly trusted, and we need to make sure that all the permission checks and all other normal controls you would apply in a web application still apply. Like all those M2 standard controls from OWASP, Open Web Security Project, right? They apply. You have to manage the configuration. You have to make sure that you check the permissions, right? And then on top of it, if you're in a cloud application, OWASP has another sub-project called weak server-side controls for cloud apps. And it has its own top 10 list, for example, exposing a non-production environment where you may have buggy code, right? So server-side controls are as important here, and I quite often seen, because of this gold rush movement where we build an app, we put some APIs, we think those APIs will never get found out. They're private, right? Not really. And I'll show you how easy it is to get there. Number 3, insufficient transport protection. And by the way, guys, if you have any questions or comments, raise your hand. We've got time, so feel free to interrupt. My only ask for you, encrypt everything. And when I say encrypt everything, I mean everything that goes over the wire. It's not insurmountable to break that crypto, but it certainly raises the bar, right? You want the attacker to go to some other app and think about something else. So using SSL is not really optional. Using SSL was tougher when the devices were weaker, the battery lives were worse. One of the reasons, by the way, if you guys don't know, BlackBerry was so popular is BlackBerry had all the patent portfolio for a type of cryptography called elliptic curve. And elliptic curve, one of the benefits of it is very low CPU requirements, right? And therefore, BlackBerry devices could last a day, which is kind of minimal battery life you want. Nowadays, it's less of an issue. Battery life is better, the CPUs are stronger, there's dedicated crypto hardware sometimes on the systems on the chip, less of an issue. But when I see something like this in a code, I worry, right? This is the first sign that somebody said, hey, we probably had a self-signed certificate, so we're just going to write our own custom SSL factory so you can just test, right? That's quicker, right? And then you see something like that. Oh, yeah, we're going to implement our own trust manager. And what are we going to do in this trust manager? Absolutely freaking nothing, We're just going to look at the cert and say, yeah, this cert is good. Go for it. That allows an attacker to do what's known as man-in-the-middle attack. So whatever your crypto is, who cares? I can put one on my own. We'll do a demo and see exactly what's going on in the traffic. Quite often people forget about this. NFC is getting very popular, especially in the Android ecosystem, but you have to encrypt. It's not out of the box. It's not as easy, but there are a bunch of exploits that can be done through there, right? So you have to make sure that the app never falls back to the HTTP. It's nice to the, sometimes we think it's nice to the user. It's not, right? Mobile networks, they can be compromised. So don't assume that even because you know the GSM is encrypted, your data is encrypted. It's not. There's this technique called certificate pinning, right? And it's becoming more and more prevalent. Basically what you do is you whitelist certain certificates within the application, and if the certificate that the server presents to the client is not one of those certs, the app should stop working, right? Because you're talking to somebody who you shouldn't be talking to, right? And there's a great article, I don't want to go into a lot of details, but there's a very detailed step-by-step guide on implementing certificate and public key pinning in mobile applications on the OWASP website that I strongly encourage you to do. All the big names like Twitters of the world, PayPals of the world. There was a recent attack against PayPal because their certificate pinning was not done right, is extremely important. Now, unfortunately, some operating systems are easier to attack than others because in order to bypass certificate store trusts, even if you didn't do this crazy, very secure trust manager that does absolutely nothing except a couple to-dos, right? You can still override some of this. And there's a talk from either DEF CON or White Hat that's specific for Android that shows, in spite of having a certificate pinning in your application, if you're doing a pen test, how to bypass all of that, because on Android, if you're running a rooted device, and by the way, if you're up, and there are techniques to discover that you're running on a rooted device, in which case most apps that have any sensitive data should probably shut down, wipe everything, and move on. If you have a rooted device, you can still make certificate pinning very, very difficult. So let's do a demo. Now let's do a bit of a demo. So the product I like to use for this on a Mac, and I don't have good recommendations for other OSs, so do your own research, is a product called Charles Web Proxy. It's a very useful HTTP proxy, monitor, reverse proxy. It does all kinds of cool stuff. So let me just show it to you real quick. Let's just get rid of this. So I'll show you basic settings. No, not for reverse proxies. Sorry. So I have it set up. I'm not going to the right setting. Proxy settings. Here we go. So I have it set up to run on port 8888. This is a lovely Mac app, so I could actually click the button and it will take over my entire traffic from this computer, not just from the apps that I care about. I can do SSL stuff. So it will do a man-in-the-middle attack where it presents its own SSL certificate, decrypts the traffic, shows it to me, and then sends it to the endpoint, and that's what we're going to do. So I can do that here. And you can do a full OS-level intercept, Firefox plugin, etc. Pretty cool tool, right? So we'll play with that in a minute, so I'm going to turn the recording on. We'll go back to the emulator. Let's see what happens. Let me log in. Oh, one thing I forgot to mention, GoDroid, in order to make it easier to do the demos, but you don't have to do it in reality, you have to set two parameters in the app after you deploy it. You have to set the target IP of the server that I'm running, this demo server that you start here that actually backs all the APIs. And then you can explicitly set up the proxy. But you don't, in a normal real-life environment, you don't have to explicitly set up the proxy. There are other ways of intercepting HTTP traffic. For example, I could have taken this phone and connected it to the Wi-Fi that is my laptop hotspot and then look at the traffic that way. Just for demonstration purposes, it's easier to do this way. So this is explicitly configured to go through the proxy. So let's try logging in and see what happens in Charles. Oh. So, and Charles gives you two views, which is kind of convenient because you could do breakpoints like a debugger, right? You can do like an API view, or you can do a sequence view like we're all used to from Firefox or Chrome, right? So I can see the request. Oh, I like this endpoint. Authenticate. I can see the client address, the destination, all the times. I can see the request. Now, this is not clear text over the wire. It's SSL, but here it's lovely and conveniently decrypted for me. I can see the response, some other summary stuff, charts, and I can actually start annotating stuff if I need anything from session to session. Very convenient if you're exploring somebody else's application, right? So let's do a couple more requests. Let's, for example, check for friends. Right, so I can start looking at list friends, some requests. I already know that this application uses a session cookie, right? I learned something very quickly, which means I can grab that session cookie and now start exercising the API myself. Can play with the response. So I guess I had no friends. Very lonely guy in this application, right? And then it searches. It did a search for friends. I guess pre-caching some data. Interesting. So they pre-cache data, right? So pretty simple way to explore this API, right? Let's maybe do some more exploring for this man-in-the-middle attack. What if we went back and looked at the first authenticate call? Anybody finds anything in this authenticate call? And I don't believe I can increase the fonts. Probably the best I can do is zoom in a bit. Anybody finds anything interesting in here? Anything jumps out in the response? There's like auto check-in, is admin, is public. If I'm somebody trying to break this in, it's like, is admin? Oh, that's cool. Some users might be admin. I wonder what app does if I'm an admin. Can I figure that out? Let's see. Well, the good news is we're running a proxy that allows me to debug all of this. So I'm just going to turn breakpoints. And I'm going to put a breakpoint on this API call called authenticate. So let's try to log in. So let me log out. Log out. And log in again. But now I get a breakpoint, right? So the HTTP call is intercepted. I can look at the request. I can edit it before it goes to the server, very conveniently. I'm not going to mess with the request. We know that there's like username and password in there somewhere. Yeah, here it is. But when it comes to the response, I think we will mess with that a bit. Why don't we make ourselves an admin? I think that's going to be pretty cool, right? Let's see. Oh, wow. Check this out. There's this new feature on the UI, manage users. Right? Since I don't know that I'm talking to the right server and the app explicitly trusted me, well, here we go. Let's see. Can I do something cool here? Reset user passwords and delete users. Oh, that's not good. But I just saw something that piqued my attention. So there's the code in this application that allows me to reset a user password. That's kind of cool. I'm going to have to dig later, but let's see what happens in the API. So when I went to get users, I got a false not authorized. So this particular application does implement the previous control, right? It doesn't trust the client. Even though I was able to sell a privileged API call, the server said, hey, listen, I looked at your session, man. You ain't admin. Go away. But I have a vector. Now I can start thinking about, okay, what else can I do? And we'll come back to this demo later, and we'll try to further explore the weaknesses in here. So let's stop the recording and go back to the PowerPoint, right? So this type of man-in-the-middle is very common and very useful, and there are plenty of tools from network sniffers to HTTP sniffers to try to figure out what else is going on inside of the application. Client-side injection. When I was studying this stuff, because we do mobile applications, that one actually is the one that surprised me the most. Because we're all familiar with things like PhoneGap. Anybody heard of PhoneGap here? Very popular framework, right? You get to write stuff in HTML, you have a native wrapper, or you just do HTML5 and you write your own native wrapper. Who would have thunk that you could actually break an app using the good old web XSS and injection techniques if it's written like that? And you don't have to believe me. We're actually going to go do a demo, but let's do some code samples. Let's say you have an embedded SQLite database, and you do stuff like this. Because, of course, we're writing a mobile app, right? why do you need binding parameters and all those other stuff we do on the server? We in a rush. The manager told us we have to launch the app tomorrow. Quickly, guys, who cares about the right framework that will make sure that this parameter doesn't have another semicolon and something else, right? Or where ID equals ID. How about that? And then we wipe the entire database locally. Let's do this. Let's send some text messages. One of the more common techniques in PhoneGap is to write something in the native code and then expose it to JavaScript interface, right? So it's easier to invoke from JavaScript. Well, guess what? If your app is susceptible to JavaScript injection, somebody else can invoke those calls. Probably not what you intended. Here's an example of a send SMS API written in Java for Android, exposed to a PhoneGap client in HTTP via SMS.js interface window object. So I can, if I find a code like this, check this out, untrusted data, I can invoke this call from JavaScript. And if that untrusted data just came from an input, hey, we got in. Now, one of the easiest way, other than doing all the standard stuff you would do on the server to prevent apps from being exploited using XSS, to prevent it is also what's called URL whitelisting. PhoneGap provides it. By default, your PhoneGap application won't be able to talk to anything but the set of the URLs you will specify in the appropriate plist file, or on iOS, and I think it's an XML file on Android, right? So XSS is a big issue. SQL injection using local storage is an issue. And you have to be very, very careful exposing your app services to JavaScript, right? Because all kind of unintended consequences can happen. Let's take a look at one example. So we're going to go back to the same app. And I was playing with the code. I basically, for the sake of the discussion, assumed that since I had the app, and by the way, here are some of the code in here that allows me to do the sniffing, right? Somebody implemented the custom SSL and put a trust manager. I love this part, right? Somebody even said, yeah, that's where I learned how to trust all certificates using, what's the comment? Yeah, right? Somebody thought they were smart by copying this from Stack Overflow into this application, and they just gave me an opportunity to execute a man-in-the-middle attack on them. So there's this thing that I found by decompiling the app called view check-in activity. It's awesome. Let's take a look at what's inside. First and foremost, it exposes some native code, like SMS.js interface, view check-in.js interface, straight to the native HTML, so I can invoke it. All right. Here's how it generates the view. So the view, I guess, is generated in HTML, and guess what? We're generating the view using normal concatenation. Ain't that cool, right? No output encoding like you would normally do on the server. We just write the HTML. And I specifically like this bit, the generate comments. If you look inside, where's that? Somewhere in here. Oh, yeah, that's the one. Generates comments, tables, first name, line, last name, count. Love this line. Basically, it takes a comment that I assume, if I'm lucky, if I'm unlucky, it only takes from the local client. But if I'm lucky, I'll be able to XSS inject this to the server, so anybody else who gets this comment gets the same exploit. And it just puts it into the HTML, pretty much as is. That's cool, right? Let's see if we can do something with that. So remember, comments, right? As is. So what I want to do is go back to the app. We're gonna hold on a second. We don't need the breakpoints. We're gonna disable breakpoints. I'm gonna go check in. We're gonna tell the emulator where we are located. So we'll just do some random location. Venue doesn't exist. Okay. Cool. Venue, free beer. I think that will attract enough traffic. We'll call this coolbeer.com. Okay, so I'm checked in. Oh, I can leave a comment. Let's leave a comment. Let's try something like this. And then maybe something, there was this thing that I could invoke a URL somewhere here. Maybe something like, window.webview.js interface launch WebView window. I like that. Window.webview.js interface. By the way, it bugs the hell out of me that you cannot cut and paste into the emulator, but we will manage. Launch web view parameter will be nice. Google.com script. What do you guys think? You think it's going to work? Probably. Otherwise, I wouldn't be demoing it here, but let's try. Voila. It just opened a new web view. It's empty because the app does implement whitelisting, so it can get out to anything but the actual API endpoint, but we're getting somewhere, right? Now, this is bad. This is not just the local one, because if you look at the actual API, where's the proxy? I turned the recording on. Every time I go back to that venue, this is now stored XSS attack because it's stored on the server, so every time anybody else checks in into the venue, let's say my competitor's bakery, I can inject my XSS and take them to my website, maybe do a promotion, right? So XSS and SQL injection, not only for the web applications. You can do some really, really nasty stuff. Yeah, finally timed out. You can do some really, and I'm not on Wi-Fi either. So you can do some pretty nasty stuff, right, if you're not careful. Big gotcha. Think about it. What if you were exposing something that allows user to place a phone call or send an SMS or execute a transaction directly to JavaScript that could be injectable like that? Nasty stuff. M5, poor authentication and authorization, right? Not rocket science. Relying on a phone number, not always a good idea. AMI, MSI, UUID, relying on them to authenticate your users, bad idea. Very small key space, very easy to brute force, right? Phone numbers, 8 digits, but if you're smart about how you go about them, very easy to brute force. Doing client-side authorization instead of the server is a complete recipe for disaster, again, unless you're Angry Birds. And servers should be authenticating themselves to the client, right? Whether it's certificate pinning, some signature mechanism, so I couldn't do what I just did and mess with the response from the server and instruct the client to do something interesting. Imagine if you were selling an app that unlocks a very expensive feature if the server tells it to. Well, if you haven't secured that, I can probably intercept the API call and just say, hey, yeah, you're good. That $100 feature, you have it. Now, contextual information during the authentication can help, but it has to be multi-factor. And by the way, multi-factor only works if it's not on the same device in certain operating systems. Because on Android, for example, I'll say, hey, listen, in order to multi-factor, you will send you an SMS. Well, guess what? If another application has a permission to read the SMS, your token just got intercepted, right? And do not use a device ID or subscriber ID as a sole authenticator. Those things get stolen, and they're very easy to brute force. M6, improper session handling. Much like in the web applications, especially in the mobile applications, especially with the tiny keyboards, we try not to force the user to open and type their password too often. Well, what does it do? Convenience versus usability, right? Long-lived sessions, tokens get stolen on open Wi-Fi. You can do some crazy stuff. How do you mitigate? The usual. One of the other things, especially if you're storing a lot of sensitive information, is ability to deauthorize the device, right? Let's say my phone got stolen and I had a long-lived session with our corporate application. We have an ability for me to go and say, hey, this phone was get stolen, regardless of any valid sessions that you have. Next time it connects, either try to wipe it if you have a mobile device management solution, or at least stop talking to it. And if you can, in the API, instruct the instruct the application to self-destruct. If you're storing a lot of sensitive data on the device, and we have HR applications, and we have customers that take their iPads to an oil rig where there's no information or no internet connectivity of any kind, so they do carry some personal information with them, we have a capability to say, hey, Mr. App, next time you connect, just kill yourself. You're stolen, right? And of course, apply usual, normal session management rules that you would in a web application. This is not rocket science. Those things are known. Make sure you get your tokens from a high entropy source, right? Because they can be brute forced otherwise. So rely on existing cryptographic implementations of your server side in order to be secure. M7. Boy, we're running quickly through this. URL schemes, very useful because unlike Android and iOS 7 and iOS in general, the applications can typically only communicate between themselves using URL schemes. In Android, intents can be abused because they can get exposed to other applications, and without knowing who is calling, you can make some decisions on behalf of the user that the user doesn't like. In most cases, it's very safe to simply prompt the user on whether they want to allow this action. And here's a Skype example. Skype used to have this lovely feature that would allow you to initiate a call, right? So you can store this URL on an address book, and you could just initiate a call by tapping on it. Well, guess what? If an attacker managed to embed something like this as an iframe in a web page a user went to visit, it immediately takes you to Skype on iOS. Skype immediately starts the call. Hopefully it's not to a number that charges several dollars a minute, and if it is, by the time you hang up, you already paid, right? So do not take certain actions if you cannot verify the source of the action without user's permission. It's extremely important to get that consent. How do you mitigate? As we said, caller permission, input boundaries, allowing and prompting the user for additional authorization, right? Do you really want to proceed? If you cannot perform the permission check, add extra steps. And here's a story from a personal experience. You know, as they say, the road to hell is paved with good intentions. As my team was building the mobile app we launched to the market about a year ago, we had really good intentions of making the app very easy to configure. So we did. We built this lovely landing page. We are hiring. This is a screenshot of the app. It's available on App Store. The marketing went, designed a very, very cool landing page, and we decided we're going to do two things. When you go to the app with an iPad, we'll give you the splash screen, and we're going to give you two-step. Very simple, very easy to adopt, two-step. Step number one, get the app from the store. Step number two, come back to this window and click on this link, and we'll just configure the app for you. Just hook it up, make sure it points to the right server, all the URL endpoints, all that good stuff. And then, of course, if you want instructions in the email, we kind of give you the email instructions. Now, this was never launched like this. We caught it in our security testing. That's why security testing is important. But the way it worked is like this. We had a particular URL scheme in iOS. Was an endpoint called settings, where we could pass the API endpoint, right? The TB Taleo net, API, REST, mobile, customer ID, blank. So when you tap on that link in the browser, we were listening on this URL scheme. The app would open, reconfigure itself to point to that server, and then prompt you for credentials as a user. Who can tell me what's wrong with that? Anybody? Come on, guys. I know it's morning. I know we all drank heavily yesterday. But this one should be easy. Any thoughts? Where is it broken? We were taking an untrusted action. In the initial version of the application, this would happen transparently. The app would open, change its own configuration, and immediately prompt you for username and password. So if I am an attacker who wants to get your credentials, all I could do is send you an email saying, hey, listen, click on this link, and you'll be taken to the app to approve an offer or hire somebody. You would go to this link. The app would silently point to attacker's server instead of ours, and the client would blindly send it, especially if certificate pinning is not there, the client would just blindly send the credentials to a third-party server, right? So obviously the way it's mitigated now is we still like the convenience, like we still want to make it easy to configure our application so the user doesn't have to type this URL. But now, every time you tap on this, the app will open. It will show you a prompt saying, hey, you're about to change the server I'm pointing to. Only do that if you were instructed by an authorized Oracle Taleo page. Are you sure you want to proceed? And if it's yes, and we actually sometimes highlight what are the right URLs, only then we would allow the user to do that. This was, Pablo and I were working on that one. This was an interesting one that we caught, right? M8, side channel data leakage. It's also an interesting one because we talked about the data being able to leak from the device what you store. And when you store the data, it's fairly intended consequence, right? You typically know that you're storing the data. It's much easier to catch. Unfortunately, in modern operating systems, the data can leak through all other kinds of means. And we'll show you an example that I consider pretty cool on iOS, right? Typically, side data leakage occurs when you mix not disabling certain platform features, right? And you have programmatic flaws. Web caches that you forgot about, right? Screenshots, I'll talk about that one. Logs. I've seen applications that log, you know, hey, about to send a REST API call with folder headers and the user's password right there to the log. So if the attacker has the device, and by the way, if your device does not have a code on it, you've seen how easy it is to get into the data, I've got your creds. Temporary directories where some data gets stored and never gets destroyed. There's really, really cool one on iOS. I love this now. And this goes to really understand the OS tweaks and specific limitations if you don't want to get hit accidentally. Here's a little line from iOS Developer Guide. It says, hey, listen, you should really remove the sensitive information before moving to the background. And when the application transition is taken, we actually take a snapshot so we can show it in a task switcher, right? So we'll give you an opportunity to hide any type of sensitive information from the UI when we do that. Otherwise, we'll take that screenshot will be stored on disk forever, or until we need another one, right? This is buried as like one tiny little paragraph, no exclamation marks, no big yellow warnings, in a multi-thousand page, probably, iOS Developer Guide by Apple. What does it mean? It means that not everybody does it. Let's take a look. Let's go back to my phone. And some people actually do it well, some people don't. Let me unlock it. So let's see. Let's try PayPal. I've recently started typing my login credentials into PayPal, and then I switched away from the app. And then, as expected, under caches, under snapshots, in the appropriate namespace, there's this file called UI Application Automatic Snapshot Default Portrait, the Retina style. But PayPal guys are good. They read the manual, so they blurred my phone number and probably the last untyped or unhidden digit of my PIN, right? Before they allowed iOS to take that snapshot. Not all applications are as good about doing this. Let's see who else. Let's try my bank app. Let's see if they know what they're doing. Where's my Wells Fargo app? Library. Oh, I guess I haven't used it in a while. Let's see. Let's do a live demo now. We have time. So what I'm going to do is I'm going to open the app. I'm going to type my username. I'm going to type a dummy password. I'm going to switch away from this app. I don't know how often this refreshes, so I'm just going to unplug and replug. Let's see what we can find. Apps, Wells Fargo, library, caches, snapshots, mobile banking, main. Oh, they forgot. So, now you know my username. Not my real username, please don't try. I like my bank account as it is. And potentially if the password was not hitting, or if I was on the screen where I was capturing my security verification, you know, what's your mother's maiden name, what's your high school, what car did you drive? All of that is now stored on disk. I have no control over that, right? Here's an app that didn't do it right. I should go file a bug with them. Here's another financial app that does something differently. So we've seen PayPal does it the right way. Let's try Fidelity, my brokerage account. Caches, snapshots, main. They just simply replaced it with a static file because I was actually looking at my stocks, right? So site data leakage occurs at all kind of weird places, and we're still in the gold rush. We're moving quickly. We're building those apps. We don't always have. Who here said, hey, listen, we're going to have, who had a project like that? We're going to have a mobile app tomorrow. We're going to take 2 engineers, we're going to send them to a course for a couple days, and then they're going to put an app on the market. Anybody? Yeah? Yeah. How many of them actually gotten security training as part of that, especially in the platform they were writing that app on? Not many, probably, right? So stuff like that can bite you pretty badly and can be pretty embarrassing, especially if it was a screenshot with somebody's salaries. Cool stuff can happen. All right, so how do you mitigate? As we said, you need to understand your platform. You need to make sure you manage your features. You never log credentials, right? It's quite easy sometimes. Hey, we'll log credentials for debug because those QA guys, every time they file the bug, they tell us they typed in the right password, but half of the times they didn't type the right password. We'll just log it. We'll eventually disable it before the app goes to production. Absolutely. Trust us, we will disable it. Yeah, right. Removing sensitive data before screenshots are taken, and the platforms provide APIs now. There was this famous case, there's an app very popular in States called Snapchats for kids to send themselves pictures that destroy themselves, but you could, of course, very quickly take a snapshot. So iOS now has an API that tells you, hey, a snapshot of you is about to be taken if you want to do something, right? Make sure that keystroke logging is disabled, so if you're using UI web view, so the browser doesn't accidentally cache the creds. Use the standard anti-caching directives like you would with a typical web app, right? This stuff still applies. And then play with your app. Grab a tool like I just showed you. Grab an equivalent tool for the Android, and right before you're putting it on the store, use it and then go exploring. Check the disk, check the temp files, check the caches. Think about what is it you're going to give to the attacker to play with as their starting point into your applications, right? You have to review the third-party libraries because you can do whatever you want to do, and you can be very diligent about your code. But all it takes is one third-party library that you've accidentally embedded into your product that doesn't do any of that, and you just lost the battle. And of course, you have to test it. Not only you have to test it on different platforms, that's a given. Sometimes you have to test it on different versions of the same platform because guess what? Things change from iOS 6 to 7, from Android 4.1 to 4.2 to 4.3, right? So you need to make sure that your app behaves and the security features behave as expected if you don't want to be surprised. M9. And personally, by the way, I do think the fact that it's M9, maybe you could argue about the priority. Broken crypto, right? There are two primary categories. Either somebody did not know what to do with an existing library, didn't configure it correctly, didn't get the data from the right entropy source, or somebody decided, hey, I took this crypto class in school, I remember it, it was pretty cool, I should really go build something. And they do. We saw that news article, right? The WhatsApp guys. Encoding is not an encryption, right? Get it out of your head. I've seen so many people talking, but hey, data is secured, it's encoded, right? You can't look at it. Well, it's not an encryption. Obfuscation, not an encryption. Serialization of your data from binary format to disk, not an encryption, right? Unless you've taken a proper crypto library and encrypted it. And by the way, make sure the key is secure, because if the key is right next to the data you've encrypted, well, you just made my life more difficult for 10 more minutes. Because eventually, if I'm really interested in your app, I'll find it, right? Don't store the key. Ideally, the key either has to be stored in some secure enclave that the OS provides, or that ideally natively in hardware, the hardware provides, or you store it on the server. Make sure you leverage battle-tested crypto libraries. And yes, I know there's been a lot of news about NSA inserting backdoors into a lot of standard cryptography algorithms. I would argue that NSA, for most of us, is the least of our worries. Let's get a crypto that works, and if NSA can get in, so be it. Better than rolling your own. And of course, make sure you know what the platform offers. The platforms are getting serious about mobile security. So using the features that the platform offers is probably your best bet rather than rolling your own. Last but not the least, sensitive information disclosure. We look at this differently, right? You can store sensitive information explicitly and understand that M10 is really meant to talk about embedded and hard-coded sensitive information, and we'll do a live example of that. Because the apps can be reverse engineered, right? Decompiling a Java app, APK, quite easy. Decompiling Objective-C, a bit more complex, but doable. If you're in any other platforms, not that big of a deal, and we'll talk about that magic number I showed at the very beginning when it comes to decompiling probably a C or an assembly written code. Code obfuscation does help, no questions about it. So if you're trying to make sure that the attacker against your app goes to your competitor's app and you have code obfuscation and they don't, yeah, it's like an arms race. Probably helps. But it's not a guarantee, so don't rely on it as a guarantee. Some of the more common found treasures in the code, API keys, passwords, sensitive business logic, like the magic formula, right? Why do I have the same slide twice? Don't know. Like, stuff like this. Hey, if the password is I am so smart, somebody will decompile and get the string. The first thing I will do when I decompile, even before decompiling the code, you run the lovely Unix strings command, and you get all the strings from the file. Stuff that comes out is pretty cool. Or if you really have a secret sauce formula, don't put it on the client like that. Somebody will decompile it. There was a mobile messenger, who I shall not name, whose authentication hashing mechanism for the phone number was hard-coded into the app, like this. Very easily decompilable, very easily repeatable. Right? The term private API keys is called that for a reason. It's meant to be private, right? It doesn't belong on the client. And if you need a solution that requires private public key, figure out something else. But do not put your private symmetric server key on the client. Somebody will get it out for you. Keeping proprietary and sensitive business logic on the server is the way to go. There's never a legitimate reason, almost never, for the sake of this talk, to hard-code the password in the client. Because sometimes, and by the way, quite often, people will do that early on. There's a gold rush. We're moving quickly. We're building the mobile APIs. We haven't quite figured out how the authentication is going to work. Or the guys that are building the OWASP server, they're not ready for us. So we're just going to do basic OWASP for now. And we're going to put some hard-coded credentials because as a developer, I'm too lazy to type it every time. And I promise you guys, I will remove them, both on the server and on the client. But oops, I was on vacation when we launched the app, so I forgot. That happens. And that does happen. This is not a real app example, but we'll look at how it can happen in this lovely for goats application. So let me log off first here. So, as we talked about it, I can go and play with the code. I can decompile the code. And obviously, since I'm interested in that, remember at the very beginning when we started looking at the authentication call. Let me do this again. Where's the authentication call? Here we go, the isadmin one, right? I'm really, really interested to see what else can I do as an admin. So if I was to decompile this app, I would probably look for all the jar or all the class files that look for the string and start there. One of them happens to be a very interestingly and aptly named one called login activity, right? In Android, that's the screen that backs the login screen. Well, let's take a look. Username, password, remember me, previous activity. Oh, that's cool. Check this out. Not only it captures my password, but when somebody wants to store it for remember me, I'm going to store it as a separate preference called user info, but I'm going to make it world readable. M1, right? The first vulnerability we're talking about. Do not store stuff where you don't want it to be found, especially like that. Especially somebody probably who wrote this, it was a quick auto completion and Eclipse. I just, what can I get here? Let's see, what modes can I get here? Or quite often this probably was grabbed straight from Stack Overflow. Can I autocomplete? And I hate Eclipse, sorry guys, I'm an IntelliJ guy, so every time I'm in Eclipse, I struggle. Mode. Yeah, I didn't really know what I wanted to do. Private sounded too complex. I was just going to make world readable, whatever, right? Well, we've gotten past that. So then the activity reads the username from the UI, right? Or sets it, pre-populates the remember me. Here's the check credentials. So we have the validate async task. If the text is there and the password is there and the fields are completed, right? So this lovely validate credentials task is probably how I could have found sorry. Shows you how much I know Eclipse, guys. What am I looking for? Yes, that's what I'm looking for. Yeah, so this is the task that does the validate credential validation. Where is it? It's somewhere further bottom. Doesn't matter. That's where I would have gotten the REST client and all those lovely certificate overrides that we looked at earlier. Oh, here it is. Here we go. So we'll grab the creds, grab the password, create the login, send this to a server. Excellent. And then on success, here we go. I get the username, I get the preferences, and if it's an admin, I launch admin home activity. We saw that. Remember, we messed with the UI, we changed the isAdmin that came back from the server, got to the admin screen. Well, in addition to that, somebody also left this lovely treasure trove for us in the code. I probably was there temporarily as they were building an app. They almost meant to take it out. If your username happens to be customer service, and if your password happens to be that, we'll also send you to the admin activity. And that makes me wonder when I look at the code like that, when it decompiles. Are those credentials only valid on dev and QA? Or can I actually try them against production? Let's see. So let's log off. So the username was customer service. Okay. Now I will not attempt to type this. Oh, I did not want to launch Parallels right now. I will not attempt to type this. Let me just kill Parallels before it takes over my computer. I will not attempt to type this, so I'll just copy it from an SMS I sent to myself earlier. As my friends told me, when you start sending SMSs to yourself, it tells you you're really, really lonely. It's not the case. That's the easiest way to cut and paste stuff. But come on, switch. Let's go into the messaging app. Message details. Come on. Do I tap and hold? Yes, copy text, good. So now I have it in my buffer, so I don't have to type this. Let's go back into the app. And delete the old password and paste the new one in. Okay. So I've gotten to this. We've been here before, right? We messed with the server before. My hope now is when I do the next click is the server will actually recognize my creds. Now, this may seem naive and simple, because it does, right? But the scenarios that I'm talking about, they're not that big of a stretch, right? People do those things. We're rushing. Mobile is important. God knows how many times we had a conversation in the office like, hey, our competitors are moving faster than us in mobile. We got to go, 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 go. That's the stuff that happens when you go fast. All right. Let's see what else we have. And this stuff, by the way, doesn't only apply to mobile. As I was preparing for this talk, and just to demonstrate how the attackers of those typical applications think, because they're not malicious quite often. I was reading this article on the web about D-Link. For those of you D-Link router users, pay attention. You may do something cool tonight when you go home. There's this guy who says, hey, listen, Saturday night and I have no date. A geek, I guess. And I have a 2-liter bottle of Shasta, which is good wine, cheap wine, and an all-rush mixtape. Let's do some hacking. And the guy was really interested in D-Link firmware, and of course, since firmware on the routers can be upgraded, he decided to download it. And there's a long write-up on decompiling, and about within 6 hours, he managed to find a piece of code like that in an OS-check code that says, hey, listen, if the URL is to /graphics or /public, you authenticate it. But also, consider yourself fully authenticated if the user agent is set to this lovely string, right? Somebody needed a backdoor. Now, if you think about this lovely string and actually reverse it, it will explain what it means. Somebody truly wanted to be clever, and they created the backdoor, but then they obfuscated it, right? So, don't do stuff like that, because there's a lot of people with their idle time on their hands and with an agenda, not always an agenda, sometimes. I'm sure this guy's had nothing against D-Link, he just wanted to play. Well, at the end of the day, there's a huge article right now, and if you do have a D-Link and there's a list of models that are vulnerable, play with this. Open your browser, change the user agent, see if you can get into your management interface without a password. I know I'm going to be messing with some of my friends. Because a couple of them are on D-Link in the house, so I'm going to go for a visit. We'll play with some internet settings. Tools. There are a variety of tools that are available for testing, and I only showed you guys 2, right? I showed the iExplore for iOS, I showed the Charts Ploxy, but you get the idea. In order to get started, find a good tool for a platform that allows you to inspect the disk, and then find a good tool that allows you to watch the traffic, right? Those are the fundamentals. In addition to that, there are things like input fuzzers, right? Tools that will automatically run different inputs through your UI. There are very useful automation tools. There's an equivalent of Selenium and WebDriver for both iOS and Android, so you can start scripting attacks and automatically execute anti-XSS stuff. Like the way we do automation for our iOS apps. Pablo, do you remember the name of the framework that the guys use? There's a framework that basically you embed into your app and in debug, and we have 2 separate builds because we would never ship this to production. It opens a port, and we can instruct the app what to do, which data to fill, as if you were instructing a browser, right? It comes in handy for regression security testing or XSS testing or input fuzzing, making sure your app doesn't crash or buffer overflows on OSs where it's relevant. Obviously, download GoDroid. It's a lovely app. I'm actually somewhat disappointed with the OWASP guys because they didn't publish the blueprint. Like all the M1 through M10, there are examples in the code, but you're going to have to do a bit of a hunting. And if you want to apply pressure, I tweeted at the guys a few weeks back saying, hey guys, you really should publish this blueprints for where to find all of those vulnerabilities. But it's a lovely project. If you want to use it in-house to show your development teams what not to do, comes in handy. There's another one available for iOS as well with similar exploits, right? So, as we wrap it up, and I am ahead of schedule, which is good. This is the first time I'm doing this talk end-to-end, and the organizers were very kind to me and gave me a lot of time. You know, mobile is a fact of life. It's only going to get worse, right? We as application developers are going to be requested to deliver more sensitive and more interesting functionality on those devices. We have to be able to get ahead of the curve, learn what to do, learn what not to do, make sure we train our teams. At Oracle Taleo, we actually, in addition to doing in-house testing, and as I said, there are 4 security teams that I can count at Oracle. There are probably some I don't know about yet. We have secure coding standards. So think about developing those for mobile. You can use OWASP Top 10 as a foundation in addition to those vectors that I've described, M1 through M10. They also describe standard controls you can apply to verify that you're compliant with best practices. Get a third-party pen test firm. If you're really worried about your reputation or you're worried about the type of data your application deals with, again, if you're not talking Angry Birds, right? If you're talking financial apps, business apps, apps that deal with PII, spend the money, hire a third-party pen tester. Those guys know what they're doing. They've been doing it for years. They'll find things and they'll surprise things. We train our developers in secure code practices at least once a year, and every time we bring a pen test, and we bring a third-party pen tester at least every year, they still will find some interesting, unique things that we may have missed, right? Security stuff. Security by obscurity does not work no matter what people tell you, right? Because the moment the app left your shop, it's on the user's device, you don't own it, you don't control it, the device can be easily rooted. So assume the client cannot be trusted. Client is the hostile witness, if you want to use the legal talk. Also, make sure that you know your platform security APIs and you understand the platform. You know, we had a gentleman who works on our mobile team who used to be the guy who used to port Java at Apple to OS X. And then he came to Oracle to do the same. He worked on the JavaFX team, came to our mobile team. He knows iOS inside out. Sometimes we still get surprised, like the little screenshot feature, like buried lovely in this documentation, right? Will surprise even the expert. So make sure you focus on understanding your platform and the security features you need to worry about them. Same for Android, same for Windows Mobile, if you, God forbid, have to work with that. And I think pretty much everybody else kind of died off. The other thing is hybrid apps. Popular, very useful, easy to get started, easy to neglect best practices. Things like injection, things like XSS, things like exposing services to the JavaScript, right? So make sure you don't forget about those. And things are changing. God, this device didn't exist 7 years ago. Right? Well, this one didn't exist a year and a half ago, but stuff is changing. The capability we have on the devices are evolving constantly. The attack vectors are showing up. I'm looking forward to the first one. So Apple in the new OS launched what they call low-power Bluetooth, or iBeacon, as it's called, right? I can only wait till the first time somebody finds some vulnerability in iBeacon and exploits it. It's not an if, it's a when. And this stuff changes, so unless you're willing to invest in this, and if you're writing a mobile app that deals with sensitive information, you have to be willing to invest in this. You need to go to your management if that's a challenge and show them some of those articles of what happens if you don't invest. You know, as I said, we all love to have a news truck in front of our building where we work. Hopefully it's the good news, not the, hey, this company just lost, well, in our databases we store information about, by now probably about 400 million people across the world. In 2011, we processed 15% of everybody. 15% of everybody who was hired in the United States was processed using our applications. We have a lot of data. We don't want the news tracks. Further reading, obviously the top 10 project. There's a good book actually on mobile application security on Amazon that you can get started with. There's the original OWASP mobile top 10 presentation on SlideShare, and there are a few actually others that are variation on that routine that talk about some of the things that this particular presentation didn't cover and the original guys didn't cover as well. So spend some time. Now, we do have plenty of time, so I'm ready for your questions.
Have you tried one of those against one of the popular, let's say, NFS or cloud?
Sorry. Can you just, yeah.
Okay, so the question is, have you tried one of those against one of the popular cloud or NFS?
Given that I live in a country that has 3-letter agencies, I can neither confirm nor deny that in my spare time I may have played with some of the applications on my phone to see what they do or do not do, and may have found certain things that did not encourage me. Let me just put it that way. And again, guys, you have to be really, really careful with this. It depends on your jurisdiction, depends on your local laws. It's very easy to get in trouble. This is powerful stuff, and unfortunately, it doesn't seem like too crazily complex, right? Child's proxy is not rocket science. It's a proxy. And iExplorer to look at your device, not rocket science either. So you have to be really, really careful with this, because I've seen people get in trouble because they pissed off the wrong people, and it's very easy to get in trouble. So that's what I'll say to that. Any other questions? Going once? Yes. Yes? No? Yes? There's a question at the back. I was hoping. Otherwise, we're going to wrap up early.
You've mentioned about PhoneGap,
yes.
And do you use it in production? Can you tell us something?
Two things. And actually, Pablo did a lot of work early on. When we looked at PhoneGap, we ended up deciding on a similar approach, but against PhoneGap itself. And if you want to hear more, Pablo here did a bunch of prototypes and a bunch of research on why. But hybrid app is the kind of direction we're going. In addition, if you look at Oracle, you may have heard that we have this technology called bigot, right, which is the technology for metadata-driven declarative applications that we sell to our customers and we use in-house. There is a subset of that technology called mobile ADF, which is, again, declarative framework for developing multi-platform web apps. And by the way, PhoneGap is super attractive. I remember first time I wanted to play with that, much like that guy. I was sitting in the house over Thanksgiving. All my friends left somewhere for vacation, and I wrote an app for myself to capture a picture of an expense report, a receipt, and submit it to my expense report system. And I was done in 2 or 3 hours after learning phone. It's pretty cool, right? Easy to get started. Knowing what I know now, I looked at that code and I go, oh, shit. You've done a bunch of stuff you're not supposed to do. But it's very attractive, especially if you have to deal with multi-platform, right? One of the reasons we love iOS, it's very easy to build. The OS is very consistent in terms of the device penetration. I think iOS 7 is over 60% penetrated by now. Unfortunately, Android is a fact of life. And you know, the beauty of the Android is the resolutions are different, the feature sets are different, the device power is different. We had a tech talk from a guy from jQuery Mobile who can tell you a lot of interesting things about differences between the browser and different versions of Android and what it does and does not do and what renders and what doesn't, right? But yes, so ADF Mobile is based on PhoneGap. We use Cordoba underneath, etc. So it's kind of derived from that. And we used PhoneGap and in production as well. Hopefully that. By the way, the other most popular app that I personally use, at least on iOS, it's a hybrid app, is Gmail client. Right? That thing is pure HTML if you kind of take it apart, which again I cannot confirm or deny that I've done. It's a pretty, and they managed the performance pretty well, right? There's a separate conversation, maybe one day we'll write a talk on mobile performance of hybrid applications, because there's certain things, for example, on iOS that you cannot do, or the browser on iOS still, I don't know about 7, but in 6, Apple has this JIT technology for JavaScript called Nitrous. But it only works in Safari. If you're launching UI WebView, it doesn't, right? So your JavaScript runs slower if you're running embedded, and performance and user experience is extremely important on mobile. So, any other questions? All right, one last question before we wrap up. So at the beginning of the talk, I've asked you, how many of you guys have passcodes on your devices? And I think 4 or 5 people raised their hand. So who thinks that by the end of the day, they're going to have a passcode on their device? Okay, I guess I didn't convince them yet. All right, well, take the risk. At least you're now educated about the risks you may be taking. Thank you very much for your time, guys.
Thank you very much.